In this video, I'll be taking you guys through a complete walkthrough of the Riverpod state management library for Flutter. We're going to be building an application that is going to be communicating with the PokeAPI and displaying to us a list of the different Pokemons that are available on that actual API. And we're going to be implementing all of this functionality using the Riverpod state management library. This list is going to have Pagination built within it, so I'll show you how to implement Pagination using the Riverpod state management library. We'll also take a look at how to implement these beautiful loading animations that you're seeing here for the actual data that's being consumed from the actual API. We're also going to be implementing the functionality of the user being able to select different Pokemons as their favorite Pokemons, and then this information being displayed at the top of our application under the favorites heading. And these Pokemons are going to be then persisted within the actual device's storage. So when the application is opened another time by the user, then all of this data is available and is not lost. We're also going to be doing this using the Riverpod state management library and shared preferences. So this video is going to be epic. You're going to be learning a lot of cool things within this video. And as always, if you're enjoying the content, then don't forget to leave a like on the video and subscribe to my channel so that you get notified every time I release a new video. And links to all of the resources that I mentioned within this video, as well as a link to the source code, can be found in the description below. So feel free to take a look at it if you're confused at any point. So to get going, the first thing that we're going to be doing is actually taking a look at the different dependencies that we require in order to create our application. The first dependency is going to be the Flutter Riverpod package, which is going to be the package we're going to be using to implement Riverpod state management within our actual Flutter application. Just as a side note, I'd like to quickly let you guys know that if you are going to be trying to implement the Riverpod state management framework within your Flutter application, you might be confused with the fact that there exists a couple of different packages that pertain to Riverpod, namely Riverpod, Flutter Riverpod, and Hooks Riverpod. This tutorial is going to focus on Flutter Riverpod and how to integrate the Riverpod state management library with Flutter, but the concepts that you learn here are going to somewhat apply to the Riverpod package and Hooks Riverpod package as well, but you don't have to worry about those. The only package that you need to work with if you want to implement the Riverpod state management library within Flutter is the Flutter Riverpod package. So with that said, let's copy this actual dependency, come back to pubspec.yaml, and then under the dependencies heading, I'm going to be pasting in Flutter Riverpod. With this done, we are going to be moving to the next dependency, which is Google Fonts, and we're going to be using that to change the actual text theme for our application. Then we're going to be using the DO package, which is a very powerful HTTP networking package for Dart/Flutter, so that we can actually communicate with our actual PokeAPI and then get data from that. So let's take this and paste it in as well. Besides this, we're also going to be using the getIt package, which is a service locator package, and it's going to allow us to work with different services that are going to be within our application. And the reason we're using getIt is because throughout this video, I've placed an emphasis on the fact that we follow good developer practices and follow a clean architecture when we're building our application, so that it's easy for you to understand what's going on and easy for you to extend upon the application that we built. So that's why we're using getIt. So let's take this actual dependency, come back and paste it under the dependency section as well. We're also going to be using Skeletonizer package, and this is a very cool package that is going to allow us to take the existing widgets that we have and then create a skeletonized version of them to indicate to the user that the data for these specific widgets is being loaded. So with that said, let's actually come to the top, copy this as well, come back and paste it in here under the dependency section. And then finally, the last dependency that we're going to be taking a look at is the shared preferences dependency, and we're going to be using this to actually persist the information for the user for the different Pokemons that they've favorited on the device, so that this information is not lost, and when the app is reopened, that we can actually read from shared preferences the list of favorited Pokemons and then show that. So let's copy this, come back, paste it in, and that's pretty much all we had to do. So with this done, all of the dependencies have now been added to our project. There's nothing else that we have to do. Just as a quick side note, I'd like to let you guys know a couple of other resources that you can go to throughout this video. Links to these will be down in the description below so that it's easier for you guys to follow along with this tutorial. The first is, where are you going to be finding information regarding the Riverpod library? Well, for that, the actual website is going to be riverpod.dev, and when you come here, you can click on the docs button, and this is going to take you to the actual Riverpod docs. I'm going to be taking you guys through each of these so you don't have to worry about where are you going to be finding certain certain information. And by the end of this video, you should have a good understanding of how to work with Riverpod and be able to browse through the actual documentation and understand what thing does what. With that said, the next thing that I'm going to be doing is also showing you guys where the actual data for these Pokemons is going to be coming from. It's going to be coming from a website called PokeAPI.co, and here you can see all of the different endpoints and how the data is returned and everything like that. And finally, I've created an actual page on my website which details all of the resources that we're going to be using while creating this tutorial and what the links to those are, what is going to go within our pubspec.yaml file for the dependencies, as well as the different models that we're going to be using. I'd also like to let you know that the source code for this actual tutorial is going to be a paid resource. So if you're interested in downloading the complete source code, then you can click on this button and download the complete source code. This is going to help me, obviously, because you're supporting the channel and allow me to create more content for you guys. So with that, that's pretty much it. Links to all of these things will be in the description so we can get going with the actual tutorial. So before we actually begin coding, one thing that I'd like to let you know is why we use Riverpod and what it is. So if you come to the actual website for Riverpod, you can see that it basically summarizes what the actual framework does in one sentence. It's a reactive caching and data binding framework. So what does this mean? Well, it basically means two things. The first is that it's a data binding framework. It basically binds the state or whatever state we want to maintain within our UI, and then whenever something changes within our state, it updates the UI for us. So that's one part of it. The other part about Riverpod is that it also allows us to cache our data. So this means that whenever there exists some state within our actual Riverpod provider, this provider caches this information for us. So whenever some new entity tries to get this information, then it gives the already cached information to it. So it might seem a bit confusing, but don't worry, we'll take it one step at a time. But that's pretty much all you need to know about Riverpod. One other thing I'd like to let you know is that the creator of provider is the same person who has created Riverpod as well. And you can think of Riverpod as a more batteries included framework that takes all of the good things that provider did and enhances them further while also mitigating some of the issues that we had with the provider framework. So if you've used the provider framework before for state management, the Riverpod is going to feel somewhat at home and it's going to be easy for you to understand what's going on. So now that we have a good understanding of what in general Riverpod allows us to do, we can come to the docs and see what are the important things that we should take a look at and then how we are going to be navigating through these docs. So the docs have a lot of different information available within them, but the only things that you should be concerned with if you want to actually get a good understanding of Riverpod is to come to the actual introduction section and read through why we have to use Riverpod. As you can see, some of the things that are mentioned here, we're going to be implementing them within our actual application. And then once you're done with the actual why Riverpod, you can skip the getting started part, you can skip the essentials part. What you can do is actually come to the point where it says concepts, and here you can see that what are the core concepts through which Riverpod is created. So Riverpod, in the most basic of essence, is built upon two things. There are things known as providers, which are basically going to be providing us information, you could think of, and then there are things known as consumers, which are going to be consuming this information and then determining what needs to be done with the information that they have. So now that you have a good understanding of this, the next thing that I'd like to let you know is that there are a couple of different providers that Riverpod provides us. And to read more about them, what you can do is come to the all providers section and you can see that there are these different types of providers. We're not going to be using all of the providers within this actual tutorial, but we'll use a couple of them, and by using a couple of them, you'll understand pretty much how to use all of them. They just have some different use cases, but you'll understand the basic gist of what a provider does, how to consume it, and the things that are surrounding the whole ecosystem, and how to set up your application with the Riverpod state management library. So with that, I'm not going to bore you anymore with the docs. You can definitely come and take a look at them here if you want to learn more about Riverpod in detail, but I'm going to be taking you step by step through the process. So with this, we can actually minimize our browser window, come back to our actual project, and then start running it. And once it's running on the simulator, then I will resume the video. Welcome back, everybody. So as you can see, the application is now running on my simulator, and for now, we're presented with a blank screen. For now, the only thing that I've changed within the default boilerplate code that Flutter gives us is that I've created a pages folder under which I've created a homepage stateful class, which returns for its build function a scaffold. And then on the main.dart file, I've set the material apps home property to homepage, and that's pretty much it. We're going to be starting everything from scratch. The first thing that we can do is do some actual maintenance tasks, and this includes coming to our lib folder, then creating a new folder here called models, and then coming to my actual website resources, and then basically copying these different model files and then placing them within this models folder. And what they are basically going to allow us to do is basically model the responses that we get from our API, as well as some other state that we manage within our actual application using an actual Dart class. So what you can do is come to models, create a new file here called pokemon.dart. Then what you can do is basically come to the resources that are mentioned here and just copy all of the code here by clicking on the clipboard, and then just paste it here like so. And that's pretty much all you have to do. And what these classes are going to allow us to do is basically when we get data from the PokeAPI, we're going to be taking that JSON and converting them into a Dart class instance so that it's easier for us to work with the actual data, one, and to also mitigate issues, because now we're going to have some type safety built into our application. So with that said, that's pretty much all we have to do. So let's close this. And with that said, I'd like to let you know that I have also created the homepage data class, which you can copy and then come back to the models folder and create a new file here. And you're going to call this the same name that's here. So it's called page data. So let's do that. Dart, and then paste this here, and I'll come back to what this class does and how we're going to be using this and everything like that. But for now, let's keep it like this and let's move on to the next part. So for the next part, what I'd like to do is actually focus on our homepage and actually see what our homepage is going to be doing and how and where we're going to be getting our data from. So if you take a look at the completed version of our application, you can see that our homepage consists of a couple of different parts. We have a grid view at the top, which shows us a list of our favorite Pokemons. And then at the bottom, we also have this list of all the Pokemons that are available on the PokeAPI. And then we're getting this information from the PokeAPI. So let's do this. Let's actually mark out the sections for this UI. And then from there onwards, we can actually take a look at how to get the information from the PokeAPI for the list of Pokemons that we are seeing. So to do that, let's come back to our home_page.dart file. Let's come to the scaffold and let's start adding some stuff here. And this is basically going to allow us to mark down the basic different sections of our UI. So to get going with it, I'll do the following. Firstly, on my scaffold, I'm going to set the body attribute. And this body attribute is going to be a call to a function, which we are going to pass the build context to, and it's going to be called build UI. With this done, I'm actually going to create this function at the bottom of our class like so. So a function that returns a widget called _build UI and takes in the build context. And then within this function, I'm going to return a safe area widget. The safe area widget is going to have a child, which is going to be a single child scroll view. The single child scroll view is going to have a child, which is going to be a container. And then once this is done, I am going to do the following, which is that this container is going to have a child, and the child for this container is going to be a column, and the column is going to have a children's list, which for now is going to be empty. So what we're basically doing is just basically defining the basic structure of our UI. And the reason we're using a single child scroll view is because our UI is going to be scrollable. All of it is not going to fit within the actual height of our device. So we have to make the child scrollable. And to do that, we're using a single child scroll view so that our UI can actually extend beyond the height of our actual screen and not give us a pixel overflow error. And the reason we're using a safe area widget is so that we can actually draw our UI only in the areas that are deemed safe to draw our UI on, so that we can avoid drawing the UI where we have like this camera notch or a bottom bar on the actual device or something like that. So with that done, the next thing that I'm going to be doing is that on my actual container, I'm going to be setting its width to be the complete width of our actual device. And then I'm going to give it some padding as well. And once that is done, I am going to come to my column and I'm going to give it a main and a cross-axis alignment, which are going to be the following. So main axis alignment is space between and cross-axis alignment dot start. And with that, we can actually focus on the children's. So the children for this column are going to be two. The first is going to be the actual grid view for our favorite Pokemons, and the next is going to be the list view for all of the Pokemons that we have. So let's only focus on all of the Pokemons for now, and then we'll come to the favorite Pokemon's grid view later. So how can we do that? So for that, let's do this. Let's create a function which is called _all Pokemon's list, and it returns us a widget, and then open up its body. And then within the column for the actual children's list, let's add a call to our actual all Pokemon's list function and pass it the context like so. Once this is done, I can come back to this function, and within this function, we're going to do the following. I'll have a sized box, which is going to have a fixed width, like so. And then it's going to have a child, which is going to be a column. So let's do that. And this column is going to have a children's list within it. And the reason we're using a column is because if I come to my UI, you're going to see that we have this all Pokemons text, and below that we have a list view. So we have two things. So for that, we are going to be using a column. Once I've defined the column, I'm going to copy and paste the text in because it's very simple. Like so, there we go. It says all Pokemon. And then I'm going to come to the column and I'm going to set the main axis alignment and cross axis alignment like so. Once this is done, the next thing that I'm going to be doing is basically adding a size box after this text. And this size box is going to contain our actual list, or the scrollable list that is going to show our different Pokemons. And then I'm going to set the height for it. And the height for this actual box is going to be 60% the height of our screen. And now that this is done, I'm going to define the child for the sized box. The child is going to be a list view, but we're going to be using the list view.builder function to generate our list view. And for the item builder for now, let's do that. We're going to get the context and the index passed to us. And for now, we will just return a list tile. And then we'll replace that later on. Let's just quickly mark out our UI. And once this is done, I'm also going to set the item count on the list view to be 0 for now. And that's pretty much all we had to do. So now with this done, I'm going to come to my main.dart file and take care of some of the styling aspects of our application. So the first thing that I'm going to do is come to the actual material app and change the title to be PokeDex. Then I'm going to set the debug show checked mode banner property to false. I don't want to see this ugly debug banner at the top, so that's gone. Then I'm going to come to my theme and update the font. So to update the font, it's going to be as follows. I'm going to set the text theme property on the theme data to be Google Fonts dot, and then here you can use whatever font is available to you using Google Fonts. To take a look at all of the different actual fonts that are available to you, you can come to the actual Google Fonts website. I'll show you. It's at fonts.google.com. You can browse through all of these different fonts that Google gives you. All of these are free for you to use, and take a look at whichever one that you like. The one that we're going to be using is going to be called Quattrocento, and I believe it's Sans. So we're going to be using this. So to use this, what I can do is actually come back to my code and then basically type in the actual name of the actual font. So it's going to be Quattro, and let's actually import the package in first. And then we should have now autocomplete. So yeah, there it is, Quattrocento Sans text theme. And then that's pretty much all we had to do. With this done, if I do command save, it's going to load the actual font for us. And there you go. The font has now changed for the title that we were displaying for all Pokemons. So with this done, the next thing that I'm going to be doing is for the seed color, I'm going to be changing that to light green. And that's going to change the actual color scheme for my application. And with that, that's pretty much all we had to do. So we can close down the main.dart file for now and come back to our home page. So now our home page has a place where we need to show information for the different Pokemons that are available on the API. And what we want to do are two specific things. The first thing is that I want to load information, but I also want to make sure that I load information in chunks. And the reason for that is because if our API has 1,000 Pokemons within it, I don't want to go and fetch all of the 1,000 different Pokemons. This is going to slow down my application and put unnecessary burden on the actual server that we're fetching information from. So a good way we can mitigate this is by implementing pagination, which is the concept of loading information in chunks. And whenever the user requires more information, then we load it for them. So the way this is going to work is that on our list view, we're going to initially load a couple of different Pokemons, let's just say 20 Pokemons. And when we reach the end of our list view, we'll ask the actual provider that we create, and I'll show you how to do it, to load more Pokemons for us. So to do this, we're going to be using a provider, and that provider is known as a state notifier provider. To learn more about it, you can come to the actual Riverpod documentation, and then here you can see that it says here that it's called a state notifier provider. There's also a change notifier provider, which builds upon the change notifier class that Flutter provides you, but we're going to be working with the state notifier. And as you can see, it tells us that a state notifier provider is a provider that is used to listen to and expose a state notifier. It's typically used for exposing an immutable state, so this is important. The state is immutable, and it also allows us to centralize the logic for modifying some state, aka business logic, in a single place. So it allows us to improve maintainability over time. So what I am going to be doing is basically thinking of my home page as a page in our application. And my home page requires some information, and that information is the Pokemon that we need to display within our list view. So the way I can implement the state notifier is to basically create a provider for the home page so that that provider provides all of the information that the home page needs to function the way it needs to. So right now, the only thing that the actual home page needs is basically the list of our actual Pokemon. So what we are going to be doing, and the reason I'm doing it this way is so that you understand how to use Riverpod in the context of clean architecture and ensuring that your code is easily maintainable, is create an actual folder within my lib folder called controllers. And you can think of controllers as entities that control a certain part of our UI or a certain page, I should say. So we're basically saying that for every page, we're going to have this controller, and this controller is going to be responsible for managing the state of this page. And to actually create our controller, we're going to be then utilizing the Riverpod state management library. So within this controller folder, I'm going to be creating a new file, and I'm going to call this home_page_controller . So now the naming scheme completely depends on you. I've just decided to call this a controller, and the reason for that is because it controls my home page, and that's why it's called a home page controller. Then once this is done, within the actual home page controller, I will create a class, and I will call this home page controller. And with this done, I'm going to say that it extends state notifier, and this comes from our Riverpod package. So remember that we're extending the state notifier class, not state notifier provider, because for now we're basically constructing the skeleton of what our controller looks like or what our state looks like, and then we'll construct a provider from this class, and I'll show you how to do that. But for now, remember, it's not a state notifier provider, it's a state notifier. So once this is done, then I'm going to say that this is going to have a state that is going to be of a certain type. So what is that type going to be? Well, we'll come to that in just a bit, but let's open up the actual class. So let's come back to what is the information that this class is going to store within it and that it's going to keep a track of. Well, if you come to the models folder, I created a page_data.dart file in the previous steps, and here we have a class that basically models all of the data that our home page requires, and it's called home page data. And our home page data is basically going to only have one property within it, which is going to be a list of the different Pokemons that we've loaded. And as you can see, it's here. This actual class Pokemon list data comes from the Pokemon.dart file, and it basically keeps a track of what's the next URL from where we're going to be getting additional Pokemons from. What's the previous URL where we're not going to be using that? What's the total amount of Pokemons that are available in the API? And then the actual results are going to be a list of all of the different Pokemons that we've pulled from the API. So now you might be confused as to, hey, how you've come up with this structure. Well, I haven't come up with structure. What I've basically done is that if you come to the PokeDex API and you come to the point where you see how to get all of the different Pokemons that are available, which is using this endpoint /Pokemon, you can actually add a limit of 20 here, which is the actual limit that we're going to be implementing. And if you submit this, you're going to see that we get a JSON response given back to us. It includes a count, which we're setting here, as you can see. It includes the next URL. So this basically points to the next URL that we're going to be using to fetch the next 20 Pokemon. The previous URL is null, but in the case of the next Pokemons, when we fetch them, then the previous URL is going to be populated, but we don't have to worry about this. We're only focused with the next URL. And then the actual results list, which basically is a list of JSON objects, and each JSON object has two properties within it. One is the actual name of the Pokemon, and then the other property is the URL, which we can use to get additional information for the Pokemon. So if I take this URL and paste this within our actual browser, you can see that we get a big list of JSON printed to us, and this JSON basically contains all of the information for this Pokemon. So what I've basically done is analyzed what these JSON objects look like, and then created these helper Dart classes such as Pokemon list data or Pokemon as you can see, Pokemon list result, which basically model these actual JSON objects in the form of Dart classes. And we're utilizing them so that it's easy for us to work with the actual API. And I've done all of the hard lifting for you. So that's pretty much all that's happening. So what I'm saying within the actual page_data.dart file is that, hey, our home page is going to have a state that is going to be homepage data. This is the actual state that it's going to maintain, or the state is going to be of type homepage data, and it's going to have a property within it. And you can add as many properties you want here. If you want to maybe keep a track of the user's inputs or anything like that, you can add as many actual values here. So like I can add a string here, which I can say XYZ, and then you can add that here as well, and that's not going to be a problem. But I'm just saying that our home page data is going to only keep track of one thing, and that is going to be called the data, and the data is going to be of type Pokemon list data. And then that's pretty much all we had to do. Besides this, I've added a constructor on the actual home page data class, which is a named constructor called initial. And what this basically does is that it creates an instance of our homepage data class and then sets the data property to null. Because when we initially construct this class, when we initially construct our state, we're not going to have data. We're going to go fetch the data from the API and update that in a later point of time. So to begin with, we won't have any data. And then I have this copy with function that's available on my actual homepage data class. And this is very important. What this function is going to allow us to do is that it's going to allow us to take the already existing instance of our homepage data class that we have and update whatever data that we need to update within it. In this case, it's just the actual data, and then return a new instance of the homepage data back to us. And this way, we are going to be able to then update the state that's going to be within our actual state notifier. Because if you remember correctly, when I showed you the documentations for the state notifier, you saw that it mentioned that the state is immutable. So if I come back to the actual Riverpod documentation, you can see that it exposes an immutable state. So the only way we can update our state is by overriding the complete state with a new instance of whatever the type of our state is. So it might be a little confusing, but just keep at it with me. The actual setup for Riverpod is a tad bit more complicated, but once you have the setup down, it's very easy to actually implement functionality within your application, and it makes your life very easy to implement complex business logic. So now that this is done, we can actually minimize the browser window once again, and then come back to my actual state notifier. And here I can say that the type of data that this state notifier is going to manage is going to be of type homepage data. But you don't have to do this if there is a existing dot type, and that's the only state that you need to maintain. That you can also say that this is going to have a state of type string, but we're doing homepage data, and the reason for that is because it's going to make it easy for us to get information from our API and then save the app and have some structure to it. So now that we've created our homepage controller, you're going to see that it gives me an error, and the error is that it doesn't have an actual constructor. So let's do that. So to create the constructor is going to be as follows. I'm going to create the actual constructor for the class, like so. And then once this is done, I am going to then say that the super.state is going to be passed to it. And that's pretty much all we had to do. So with this done, we've actually created our controller. So now that we've created our controller, which extends a state notifier, we haven't created a provider yet. This is something that is just the actual structure of what our provider is going to be able to do and what are the capabilities of our provider. This class just defines that. What are the actual capabilities of our provider? What type of data is it going to store within it, and things like that. Now we need to construct the actual provider. So to construct the provider, what I'm going to do is come to my pages folder and to my homepage class. And then before I actually create the class definition, here I'm going to be constructing my actual provider. So to create the provider, it's going to be as follows. I'm going to create a variable final. I'm going to say that this is going to be called homepage controller provider. So as you can see, it says that it's the provider for the homepage controller, and it's going to be equal to, and now we're going to be using our state notifier provider. Then the state notifier provider is basically going to expect us to pass it a function this function is going to take in a widget reference, and then we need to return to it the actual instance of our controller class. So what I can do here is say that I'm going to now return my home page controller class, and it's going to work with this actual state notifier provider because our home page controller class extends state notifier. So there you go. Now we can do that. And since we are now constructing our home page controller, we need to give it the state, and the initial state can come from the home page data.initial constructor. So there we go. We've successfully created our provider. So now we've created our provider, but if we try to now listen to the changes that happen within this provider or interact with this provider, it's not going to work. And the reason for that is because there's a very crucial step that we missed when it comes to working with Riverpod. And that is that we need to actually wrap our widget tree for our application where we expect that we're going to be using Riverpod with an actual widget that is called provider scope. If you don't do this, then it's not going to work for you. Riverpod is going to crash or you'll get some weird error, so you have to do it. Since I'm going to be using Riverpod throughout my application, I'm going to be wrapping my actual material app with this provider scope widget. So to do this, I'll come to the material app, and then you can right click on it, do refactor, and then do wrap with widget. And the widget that we're going to be wrapping with is called provider scope. And this actual class is going to come from Flutter Riverpod once again. So with this done, let's do command save and let's give our application a complete restart. And now with this done, what we've done is that we've wrapped our material app with the provider scope. So now it's going to allow us to read the different providers that we create. And talking about providers, we've come to our home page and we've created our first provider. So congratulations on that. And this provider is of type state notifier provider. And then the actual capabilities of our provider, what it allows us to do, the different functionalities that are available on it, and the state that it manages is defined on this actual class that we've called home page controller. So now the last thing that we need to do is understand how can we consume this provider. That's the last missing piece of the puzzle. So to consume the provider, it's very easy. We can consume it in whatever widget we'd like to do. But in this case, since this is the home page controller, I want to consume it within my home page widget. So what I'm going to be doing is coming to my home page state. And here I'm going to be now creating an actual variable that will allow me to actually consume this home page controller. So to do it, what I'm going to be doing is that I'm going to come here and I'm going to say that I'm going to create two variables. They're going to be late. The first is going to be of type home page controller, and it's going to be called underscore home page controller. The next is going to be late again, but this is going to be of type home page data, and then it's going to be underscore home page data. There we go. Then what we can do is that within our build function, before we return our scaffold, we can do the following, which is what we do to actually read a provider, and that is that I'm going to set my underscore home page controller equals to, and then I can do ref dot, and then here I can do whatever I'd like to do. But you're going to see that we don't have access to anything named ref, and I purposefully did that. And the reason for that is for our classes or whatever widgets that we create, for them to be able to consume a provider, they have to implement or extend a different type of widget. They can't extend the simple stateful widget. In the case that we were creating an actual stateless widget, which we'll do later on in the video, the actual widget that you'll be extending would be a consumer widget. And as the name suggests, a consumer widget would allow us to consume a provider. But in this case, we're using a stateful widget. So do you guys have any guesses what type of an actual widget we're going to be extending so that we have the ability to read a provider? Well, we're going to be extending a widget which is called a consumer stateful widget. There we go. So now that we've done this, what I need to do is also update the corresponding state class for our homepage. So the corresponding state class for our homepage is going to be consumer state, and the type of this is going to be homepage. So now with this done, I also need to update the actual return type of this create state function to be consumer state of type homepage, and that pretty much fixes the issue for us. Besides this, we have no errors. So now what I can do is actually come to my build function, and now you can see that when I type in ref, we have access to this ref variable, which is of type widgetRef. And we use this widget reference to actually read these providers or access these providers or interact with them. So I'm going to do ref dot, and then we can do watch. We can also do read. So what's the difference between watch and read? Let's quickly kind of take a look at it. If you just want to read information from the actual provider that you're concerned with only one time, you're not concerned with what happens to the actual state of the provider, and you are not concerned with when that state changes that you want to get notified, then you can use read. This is going to go ahead and it's going to read the information from the provider for you, and it's going to give it to you, and then it's not going to notify you when changes happen. So it's not going to cause the widget to re-render itself if the state within the provider changes. But if you also want the ability to get notified when the actual state within the provider changes and then cause the widget tree to rebuild itself, then what you need to do is actually use the ref.watch function. And if you come from provider, this might sound similar. So within ref.watch, then you need to pass in what provider you want to watch. If it was read, then you'll pass the same provider, but that time it'll read it. I'm going to do home page controller provider. There we go. And then since I want to get the home page controller instance returned to me from this actual provider, as you can see, this is a state notifier provider of type home page controller. What I can do is do home page controller provider dot notifier. And this is going to return from this provider the actual homepage controller to me. Now you're going to get an error, but you don't have to worry about this. Just restart your application, and that is going to fix the issue for you. So just completely restart your application, and then you shouldn't get this error. And now that this is done, what I'm going to do is then also set the underscore homepage data to be equal to, and then again, it's going to be ref.watch, and then I'm going to do home page controller provider, and that's pretty much all we had to do. And now we're getting a specific error, which is that it's telling us that, hey, state notifier provider of type homepage controller, object optional can't be assigned to parameter type provider listable homepage data. So this error might be difficult to deduce what's actually wrong, but what's actually it's telling us is that, hey, you've defined the state notifier provider, and I know that it's going to be of type homepage controller, but what's the type of its state going to be? All I know is that it's going to be object optional. So here you're saying that the actual homepage data is going to be of type homepage data. So I don't know what to do, because the actual return value from this ref.watch function can be a homepage data, can't be a homepage data. So to fix it, what you can do is actually, when you're creating your state notifier provider, is actually define the type of the state notifier provider. So the first argument here is going to be the actual homepage controller. So this is the type of our state notifier. It's going to be homepage controller. And then what the state is going to be, or the type of the state, well, that will be homepage data. And if you do this, then the error should be resolved for you. And now everything should work. So again, just restart your application if you get an error like this. Whenever you get some kind of a Riverpod related error, the first thing that I'll recommend is that you restart your application, because that's usually going to fix the issue for you. And if it persists, then you can take a look at some other methods to actually resolve your issue. So with that, that's pretty much it. Congratulations. Now you understand how to work with an actual state notifier a little bit, how you can create a state notifier provider, and then how you can consume an actual provider or react to the changes that happen within this provider. And we'll slowly build our application step by step, and then you'll see how everything comes together. But now you have a basic understanding of what's going on. So to recap things, we've wrapped our whole application with a provider scope. This will allow us the ability to use these widget ref to then read the different providers that we create. And then we have created a provider that's going to be the first provider that we're taking a look at, which is a state notifier provider. There are other types of provider. We'll take a look at those as well. And then we've also understood how to create a class that is going to extend upon the state notifier and allow us to tell what the state is going to be and work with the state and manipulate it. So now that this is done, we are finally at the first step to loading information from the API. So let's do that. So let's come to the actual PokeAPI homepage. On the actual PokeAPI.co website, the actual endpoint that we're going to be using to get the list of all of these different Pokemons is going to be the following, which is PokeAPI.co/API/v2/Pokemon. And this endpoint is going to take two query parameters from us. The first is going to be a limit. So how many Pokemons do we need to get? And then the next is going to be the offset. And I'll explain to you how these work. They're going to help us in implementing pagination. So the limit equals to 20 here is that I want to get 20 Pokemon with every request that I get. And the offset 0 here basically defines that I want to get the first 20. So let's do submit, and you can see that we get a list which basically gives us 20 Pokemons, and then a next URL which basically tells us what's the next URL we need to go to get the next 20. So you can see that for the next URL, it's practically the same. The only thing that changes is the actual offset. So now if I set the offset to 20, this basically means that, hey, I want to get 20 Pokemon again, but this time I wanted to skip the first 20. And when we do that, we get another list of 20. Now, if we go ahead and we go through all of the Pokemons, and I can do that by just saying that the limit is going to be 1302, offset is 0, you're going to see that it tells me that the next URL is null. So when the next URL is going to be null, that means pretty much we've loaded all of the Pokemons, so 1302, and there's no more Pokemon for us to show. So we'll also implement the use case for this, but this is basically how it's going to work in general. So now that this is done, the first thing that we need to do is implement some kind of a mechanism within our application so that we can actually interact with the PokeAPI and get data from it. So to do that, we're going to be actually coming back to our application, and in the spirit of clean architecture, creating another folder within our lib, and this is going to be called services. Then what I'm going to be doing within the services folder is actually creating a new file, and I'm going to call this http:/service.dart. Once this is done, we can actually open the class up and then create a class here. So this service class, as the name suggests, is going to be responsible for providing us all of the functionality we need for HTTP-based operations. And then what I'm going to be doing is creating the constructor for this class, and this is going to be empty. Once this is done, this class is going to be using DO to actually service our request. So I'm going to do final_DO is equals to DO. And the reason I'm creating the DO variable and setting that equal to _DO is for the reason that I want this variable to be private, so not accessible outside of the scope of this class. And the way we can do that is by actually using an underscore before the name of the variable or function, and that marks that as private. This is just a thing about Dart. And then once this is done, for the purposes of the application that we're creating, all we need to do is have the functionality of doing GET requests. We're not concerned with post, push, delete, things like that. So we're only concerned with getting data from the API. So I'm only going to be creating one function within this HTTP service class, and that's to get data. So to do that, I'll say that I'll create a function. It'll be future type response optional. So it's going to be an asynchronous function, and in the future, it's going to return a response to us. It might return a response to us, it might not. So that's why it's response optional. And then I'm going to say get. Here I'm going to say that it's going to get a path passed to it, mark this function as async, open up its body. Then I'm going to use a tie catch block. Within the catch block, I'll print the error. And then if we reach the end of this function, I'll just return null. So basically we didn't get anything. Then within the try block, I'm going to say that I'm going to have a variable of type response. This actual class is going to come from the DO package. res is equals to await. And then I'm going to do _DO.get. And the path here is going to be the following. And with that done, the next thing that I'm going to be doing is saying return response. There we go. Let's do command save. And that's pretty much all we had to do. So now that I've created this HTTP service, I want to use the getIt package to register this service. And then wherever we need to access this service within our application, we're going to be using getX to then access it as well. So let's close down our HTTP service file. Let's come to our main.dart file, and the first thing that we need to do is register this service so that when we want to use it, we can access it. So to do that, what I'm going to be doing is basically creating a function within my main.dart file, and I'm going to say that this function is going to be future void return type, and then I'm going to say it's going to be _setup services. It's not going to take any parameters. It will be async and open it up, and then I will do getIt, and then I'm going to do .instance and then register singleton, and then within this I'm going to pass it an instance of our HTTP service class like so. So this is going to register a singleton instance of our HTTP service class, and then we'll be able to access it using the getIt package later on. And then I'll also define the type here on the register singleton function to be HTTP service. With this done, that's pretty much all we had to do. So now before I run my application, I'm going to mark my main function as async, and then I'm going to do await _setup services So once the setup service function has completed, then I'd like you to move to the next part, and the next part is going to be to run the application. So with that, we've now created our HTTP service and we've registered it using our getIt package. And if I reload my application, everything seems to be working. So now I can come back to my actual homepage controller and access the HTTP service class here. So to access the HTTP service class, it's going to be pretty simple. The first thing that I'm going to be doing is creating an actual property on my homepage controller. And I'll say that this is going to be final, type getIt. It's going to be underscore getIt, and I'm going to set it equal to getIt.instance. Then I'm going to create another variable, late HTTP service, underscore HTTP service. Then what the homepage controller gets constructed, so I'll open up the actual constructor's body. I'm going to do HTTP service is equals to, and then underscore getIt, and then we can use the get function. And for the get function, I'll pass the type here to be HTTP service. So hey, getIt, go and fetch me the HTTP service instance that you have registered as a singleton, and then place that reference within this variable. So now we can access the HTTP services functionality by using this variable throughout this actual controller that we have. So now what I'm going to be doing is actually going ahead and then creating a function called setup, which is going to be called when this actual homepage controller gets created. So to do that, I will say that now I will create this function, future void, it's going to be called underscore setup, mark it as async and open it up. And within this, I'm going to call a function called load data. Then let's actually take a look at our load data function. So the load data function, as the name suggests, load data for us. So I'm going to say that this again is going to return future void, and then I'm going to do load data like so. I'll mark it as async and open it up. So now the logic for loading the data depends upon a couple of things. And that is that if we already have data available to us, then we need to use within that actual data the next URL, go to that URL, fetch data from there, and then take that data and add that to the already existing list of Pokemons that we have. So for now, we're not concerned with that. So what I will do is create an if condition. That is that if the state.data is null, this basically means that, hey, this is the first time that we're getting data. If it's not null, so let's create an else block. This means that we already have some data, but now we need to fetch the next set of data. So we'll leave the else for now, and we'll just focus on what happens when we don't have any data. So if the state.data is null, and data here is going to be of type Pokemon list data, as you can see. If you come to Pokemon list data, you can see that it's basically a class that mimics the structure of the JSON that we get from the actual PokeAPI, where we have the count of the Pokemons, the next URL we can go to get the next amount of Pokemons, a list of results, so how many Pokemons we get, and then the previous. So there we go. So now what I can do here within load data is as follows. I've concluded that there's no data, so I need to load the initial set of Pokemons. So we're going to do that. So to do that, it's going to be the following. I'll create a variable of type response, optional, and this class is going to come from the do package. So let's quickly import that. And then I'm going to say that this is going to be equal to res. Then I'm going to set this equal to await underscore HTTP service, and then I can call the get function on it, and then pass it the path. So the path is going to be the one that I showed you guys, which is that we're going to access the following endpoint, https://pokeapi.co/API/v2/Pokemon, and then also include all of these query parameters. So let's copy this, come back, and add this within the string. There we go. And then after this, we're going to have the following. And this is the endpoint that we are going to be going to get the initial set of Pokemons that we need. So with this done, let's do command save, and let's do this. Let's do print response.data like so. And let's also make this be a nullifier operator. Then let's open up our debug console like so. And then if now I come back to my actual application and just restart it, because we are creating an actual provider, as you can see here, you can see that we get a list printed out. And the reason for that is because when we create our homepage controller provider, we instantiate an instance of our homepage controller. when the home page controller gets created, its constructor calls the setup function, which calls load data. And then the actual load data takes a look at the state notifier state, which is of type home page data. And then it takes a look at its data property. It deduces that, hey, we don't have any data currently. So it calls the actual HTTP service and gets the initial list of Pokemons and saves that within this response variable. So now that we have access to our data, which you can see here, what I need to do is take this JSON and convert that into an instance of our Dart class. So to do that, it's going to be very simple. I'm going to first use an if check to see if the response is not equals to null. And then once this is done, the next thing that I'm going to be doing is also making sure that the response.data is not equals to null. And if these two things are true, then I'm going to do the following, which is Pokemon list data. This is the variable that I'm going to be creating. And the reason for that is because the actual state for our state notifier is of home page data. And this home page data has the data property within it. And this data property is of type Pokemon list data. So I'm going to create a variable Pokemon list data. I'm going to set that data, and then I'm going to do Pokemon list data dot from JSON. So this is a utility factory constructor method on the Pokemon list data class that allows us to take in JSON and then returns to us an instance of the Pokemon list data class. So we can pass it some JSON, which we can get from response.data like so, and then it'll return to us an instance of Pokemon list data class that we save within the data variable. And then now what I'm going to be doing is the following, which is that I'm going to be updating the state of the state notifier. So if you remember correctly, the state is immutable. So this basically means that if I go within the actual state object and change something within it, then the state notifier is not going to know, oh, that the state changed, and it's not going to update its listener. So to correctly update the state, what we need to do is set the state to a new instance of home page data, because that's the type of state that our state notifier is maintaining. So what I'm going to do is say state is going to be equal to state, and then the state is of type home page data. So on this, I can use the copy with function. And for the copy with function, I can say that the data is going to be data. You could think of the copy with function as a function that returns to us a new instance of the home page data class, but it has the same data as the previous instance that was within our state, except for the fact that whatever actual parameters we pass within the actual function when we call it, those are the only things that are changed. So with this done, that's pretty much all we have to do. And now we have practically done everything. So when this line is going to be called, which is state is equals to state.copyWith, then what's going to happen is that our state is going to be now updated. And then wherever we are listening to our actual provider, in this case here within our home page, it's going to cause a rebuild to happen for our home page. And you'll see that as well. So to showcase this to you, I am going to come to the build function, and then I'm going to come to the build UI function, and then I'm going to come to the all Pokemon's list function, and then I'm going to come to the point where it says sized box list view builder item count. And now I'm going to set the item count to be underscore, and then I'm going to do home page data dot data, and then dot results dot length. There we go. And then I'm going to do, by default, this is going to be 0. And then I'm going to use a nullifier operator here, like so. So if this returns null at any point, then we're going to set the item count to 0. Otherwise, it's going to be the length of the results list, which contains the Pokemons that we have. So once this is done, I can come to the list tile here, and I can say that this list tile is just going to basically have a title, and the title is going to be a text widget, and it's going to say index. That's pretty much all we do, and let's do index to string. So hopefully now we should see 0 to 19 being printed to the actual list here. So let's restart our application. Let's see if this happens. So there we go. Initially, when it was loading the information, we didn't see anything. And then as soon as we got the data, it caused the actual state to get updated here. Then because we were actually using ref.watch within our actual homepage state here, it caused us to rebuild the actual widget tree. When we rebuild the widget tree, now we had access to the actual data. and the data was a null. So then we set the item count to be 20 now, and then we rendered all of these different elements using the item builder. And now we have 0, 1, 2, 3, and we can scroll through them all the way till 19. So there we go. We have the Pokemon data now loaded, and it's available to us. So now what we need to do is basically create the actual widget, which is going to display the Pokemon information to us in a beautiful manner. So how can we do that? Well, to do that, the first thing that I'm going to be doing is actually creating a widget, which is going to be responsible for displaying information about each of these Pokemons within our list view. So for that, I'm going to come to my lib folder, and I'm going to create a new folder here called widgets. And then I'm going to come within this folder, and I'm going to create a new file. And I'm going to say that this file is going to be called Pokemon _list_tile.dart. Then I'm going to create a class here. I'm going to say Pokemon list tile. And then I'm going to say that it's going to extend. And what is going to extend? Well, let's do this. For now, let's do a stateless widget. So it has nothing to do with Riverpod as of now. Then once this is done, we need to define the build function on our Pokemon list tile. So I've defined that. And then I am going to, for now, do the following, which is that we are going to create a function, which is going to return a widget. I'm going to say it's going to be called _tile. For now, I just get the build context passed to it, like so. And then within this, I'm going to say that I'm going to return a list tile, like so. And that's pretty much all we have to do. Then I can come to my build function and say that here, I am going to return the _tile function and pass the context to it. There we go. And then the last thing that I'd like to do is to let you guys know is that if we come to our homepage controller, once we've updated our state, let's do print state dot and then data dot, and then we can do, for example, results, and let's print the first result. Let's actually see what the first result is. Well, I know that the type of the first result is going to be Pokemon data, but let's see what it is. So let's add these nullifier operators here. Save, restart the application, and in the debug console, hopefully, it says instance of Pokemon list result. So actually, let's see what a Pokemon list result is. So come to the Pokemon.dart class, and let's scroll down, and you can see here, a Pokemon list result is basically a class which contains two properties within it, a name and the URL. But if I take a look at my actual UI, my list tile actually shows a bunch of different information about the Pokemon. It shows us the image of the Pokemon, it shows us the actual name, how many moves that Pokemon has, whether I've liked that Pokemon or not. But we don't have access to this information. We have only access to the name and URL. So what's the catch here? Well, the catch is that the PokeAPI, when it returns the results to us and the Pokemon endpoint, it gives us this result list, which contains these different JSON elements within it, each JSON element corresponding to a particular Pokemon, and then it gives us this URL. We have to go to this particular URL for each of these Pokemons to actually get information for that Pokemon. So what I can do is the following, and as you develop your intuition as a programmer, as you become more advanced, you'll understand how these different things come together and what kind of a structure you can implement within your application to effectively manage state. This is just a solution I've come up with, but what we're going to be doing is as follows. I'm going to basically pass this URL that you see here to this actual Pokemon list tile widget that I've created. And then this Pokemon list tile is going to take a look at this URL, and it's going to do whatever magic it needs to do. We'll use another type of a provider from Riverpod, I'll show you that. But it's going to take this URL and it's going to then fetch information for this Pokemon from that URL and then display that information within itself. So for now, let's only focus on how can we pass the URL to this actual Pokemon list tile. So to do that, what I am going to be doing is basically saying that this Pokemon list tile is going to have a property which is going to be of type string, and it's going to be called final string Pokemon URL. Then I'm going to define the constructor for the Pokemon list tile class. It's going to get a required named parameter passed to it, which is going to be this dot Pokemon URL. There we go. And that's pretty much all we had to do. So now with this done, the last thing that I'm going to be doing is coming to my actual tile. And then within the list tile, I'm going to set the title to be a text widget. And then here we can say that we're just going to print the Pokemon URL. Then do command save. come back to our home page, and then come to our all Pokemons list, come to the size box, to the list tile that we are returning within the list view builder's item builder function, remove this, and now say that we're going to return our Pokemon list tile. Then the Pokemon URL here is going to come to us from the actual results list. So what we need to do is access the particular Pokemon at the particular index within this results list. So how can we do that? Well, to do that, it's going to be as follows. I'm going to do underscore homepage data dot results at the specific index, like so. And then we can use an actual exclamation mark here and an exclamation mark here, because we know this is not going to be null. So the return type is going to be of type Pokemon list result. So I'm going to now say Pokemon list result. And I'm going to say Pokemon, like so, is equals to this. And then here I can do Pokemon URL is the Pokemon dot URL. There we go. That's pretty much all we had to do. So with this done, let's do command save. And there we go. For each of our Pokemons, we're now seeing the list tile being returned. And the list tile shows us the URL for each of these Pokemons. So there we have it. That's one part done. Now what we've done is that we have the actual data being loaded for the list of Pokemons, but now we need to go to each of these URLs and then get the particular information for each of these Pokemons. So let's restart our application to give it a final run and make sure that nothing's broken. So as you can see, initially when there's no data, our list isn't being rendered. As soon as we get the data, since we are listening to a provider, updates us, we rebuild the widget tree, and then we show the new list view because now we have the data. So now what I'm going to be doing is showcasing to you guys a new type of a provider. We've used the state notifier provider. We understand how it allows us to implement functionality using the Riverpod state management library to manage our state. Let's take a look at another type of a provider that Riverpod provides us, and that is future provider. So as you can see that the future provider is the equivalent of provider, but for asynchronous code. Future provider is typically used for performing and caching asynchronous operations such as network requests. So that's exactly what we're going to be doing, and that's why we're using a future provider, nicely handling error/loading slates. That's another thing that we are concerned with, and then combining multiple asynchronous values into another value. We're not concerned with this. Later on, as we develop and become more experienced within your Flutter development journey, you're going to encounter streams, you're going to encounter other types of providers, and then you're going to build your intuition, get more experience, so you can come back to this actual documentation and see what other types of providers are available and how you can use them. So we've taken a look at the state notifier provider, we're taking a look at the future provider now and how to use it, but maybe in the future you want to consume a stream. Well, for that you might want to use a stream provider, but as you can see, it says that a stream provider is similar to future provider, but for streams. So let's actually take a look at how to work with this future provider. Well, to work with the future provider, what I'll do is that I'll come back and I'll come to my Pokemon list tile widget. And then what I'm going to be doing is that I'm going to be saying that I'm now going to be creating a new folder within my lib folder. And this is going to be called providers. Then what I'm going to be doing is within this provider, I'm going to create a new file, and I'm going to call this as Pokemon underscore data underscore providers dot. So this is a file which is going to contain a bunch of different providers within it that are going to relate to providing us with Pokemon data. Then once this is done, I'm going to open this file up, and here I'm going to be creating a future provider. And this future provider is basically going to take in a URL. It's going to go get the information from this URL, and then it's going to let us know when it has that information or when it's loading that information or if some error has occurred. So to create this provider, it's going to be pretty simple. It's going to be the same way that we've done before for the state notifier provider. I'm going to create a variable final, call it Pokemon data provider. And then I'm going to set that equal to future provider, like so. Then our future provider expects us to pass it a function. The function takes in a ref, which is the widget ref, and then it's basically going to return to us something. and the return value is going to be the actual data that this future provider has actually gotten from a particular URL. Then when we're creating this actual future provider, nowhere are we actually passing it the URL that we want to get information from. So to actually construct a future provider from a particular argument that we pass, what I can do is actually do future provider.family, and then I can define on this actual family constructor what our future provider is going to return to us. So it's going to return a Pokemon object back to us. This comes from the actual models file. So if you come to models Pokemon.dart, there's going to be a Pokemon class here, and this Pokemon class basically models the JSON that gets returned to us for a particular Pokemon's data when we access it in the form of a Dart class. So the abilities that Pokemon has, its height, ID, moves, name, species, sprites, things like that. So I'm saying that, hey, this future provider is going to return a Pokemon class instance back to us, and it's going to be optional. We might get a Pokemon, we might not get a Pokemon because this is a network request, it might fail. And then we are going to pass it a string. That's going to be the actual value that's going to be passed to this future provider when we are constructing it, because our URL is in the form of a string. So now when we are constructing this actual future provider, we are going to be doing the following. Firstly, I will get access to my HTTP service. So I'll do HTTP service underscore HTTP service is equals to, and then I can do get it dot instance dot get, and then the type that we're going to be getting is HTTP service. There we go. Once this is done, the next thing that I'm going to be doing is then saying that I'm going to do response question mark, and this class is going to come from my DO class, or DO package, I should say. Response is equals to, and then do await. And one thing I forgot to mention here is that this actual function needs to be marked as async, because we are performing an asynchronous operation. And once this is done, I am also going to say that now, since we are saying here that, hey, future provider, you're going to return to us a Pokemon optional, and you're going to get a string passed to us. We, within this function, are not only going to get this actual reference passed to us, but this actual string value passed to us as well as the second argument. So I can do, for example, URL here, but you can name this anything that you'd like. This basically corresponds to the actual type that we've defined here. So then I'm going to do getIt.instance.get, and then we're going to be getting our HTTP service. Then I'm going to do await underscore HTTP service.get and pass it the actual URL that gets passed to us, like so. Then I'm going to do if the response is not equals to null, and the response.data is not equals to null, then you can return to us the following, which is Pokemon dot from JSON. So again, this is a utility function that's created on the Pokemon class that allows us to pass it JSON, and then it returns to us an instance of our Pokemon class. So I'm going to do Pokemon, and then we can do response.data, like so. And then once this is done, I'm going to do return null. There we have it. That's all we had to do. And now we've created our provider. So now to consume this provider, what I can do is come back to my Pokemon list tile, and then I am going to say that this Pokemon list tile is now going to extend a consumer widget. It's not going to extend a stateful widget or stateless widget. And when we extend a consumer widget, the build function gets another argument passed to it, which is of type widgetDef, which is the reference argument, and we use this ref to then basically consume this provider. So now what I'm going to be doing is then coming back and doing the following here, is that within the actual build function, because we have the actual reference being passed to us, I will read the actual Pokemon data provider here by doing ref.watch, and then I'm going to do the following, which is Pokemon data provider, and then this Pokemon data provider requires us to pass it an actual URL. That is going to be the Pokemon URL that gets passed to this Pokemon list tile. So let's give it that here. And that's pretty much it. And there we go. So now with this done, as you can see that this actual ref.watch function is going to return something to us. So I can save the actual return value within a variable, which is going to be final Pokemon There we go. So now this Pokemon is going to have a async value variable saved within it, which is going to be type Pokemon optional. And there we go. That's pretty much it. That's all we had to do. So now what I can do is the following. I can come back to where I am for my build function, returning this tile. Instead of this, I'll copy this and remove it. And I'm going to do the following. I'll say Pokemon is the thing that we're going to return. But on that specifically, I'm going to do Pokemon.when. So what this basically is doing is that on our future provider, it's saying that when our future provider has data, it's going to call this data function, and then we return an actual widget from here, and that gets returned. When it's in its error state, we call this error function and it returns a widget. When it's in loading state, we call this loading function, and then the loading function returns us an actual widget. And then all of the actual loading state logic, error logic, everything like that logic is handled by the actual future provider. So for the data function, we get data passed to us, and then we can basically say that we can return whatever we'd like. What I'm going to do is say that I am going to return _tile and pass the context here. There we go. And then for the loading function, I'll do the same thing. When we are loading, we are going to use the following function, callback. And then here I'm going to do the same thing, which is return loading. There we go. And then for the error function, I will say that we are going to get two properties passed to us. One is error, the next is stack trace. And then here, I'm going to say that I'm going to return a text widget. And the text widget is basically going to have a string within it, which is going to display to us what the error is. There we go. That's pretty much all we had to do. So as you can see that the future provider is making it very easy for us to work with these asynchronous operations and is allowing us to efficiently manage the different states for this asynchronous operation and what gets returned as a widget for these different states. So when we have data, we return this tile. When we have loading state, we return this tile. So for now, there's no difference, but we'll see how to use the Skeletonizer. And then when we have an error, we return this actual text. So let's do command save. Let's come back to our tile. And then within our tile, let's do this. Let's say that now our tile is going to take in two more parameters. The first is going to be a Boolean value. So are we loading the data currently or not? And then the last thing that we'll pass is this Pokemon optional, which is going to be the Pokemon. And there we go. That's pretty much all we had to do. So with this done, I'm going to come to my list tile, and I am now going to be wrapping this actual list tile with a Skeletonizer widget. So to do that, you can do Control-Shift-R on Mac, or you can right click on it and then do refactor wrap with widget. But I'm going to do Control-Shift-R and then wrap with a widget. The widget that we're going to be wrapping this with is called a Skeletonizer widget. There we go. And then what I'm going to do now is basically say the following, which is Skeletonizer, and then you can do Skeletonize property on the actual Skeletonizer. So you do enabled, and let's do true for now. Let's see how it looks. So with this done, I can come back to the tile here, and when we have the data, then the isLoading is going to be false, and we'll pass the data here. There we go. And when we are loading, then for the tile function, I'll set the isLoading to be true, and then the data will be null. There we go. Let's save it. And as you can see, the Skeletonizer is now in action. You can see that since the actual Skeletonizer has been set to true, it has skeletonized the actual list tile, and it's showing us this beautiful loading animation. As soon as I set this to false, then that loading animation disappears, and now it's just showing us the list tile without the skeletonization applied to it. So now I can set the isEnabled property to isLoading, and now when we're loading the data, we see a skeletonized version, and once the data has been loaded, it shows us the unskeletonized version. There we go. So now we've implemented our Skeletonizer, and as you can see, the future provider is working as intended as well, because when we have the data, then it goes away from showing us a skeletonized version towards showing us the actual data. So now what I have to do is just basically add all of this information that I have gotten within this actual Pokemon variable that gets passed to us to this list tile. So let's do that. So the first thing is the title. So let's update the title. So now the title is not going to show us our actual Pokemon URL. The title is going to depend upon whether we have a Pokemon or not. So if the Pokemon is not equals to null, then what we are going to be doing is for the title showing Pokemon.name.toUppercase. And then if the Pokemon is null, then I'm going to basically just show this string, which is currently loading name for Pokemon. And the reason we're doing that, I'll show you now. Is now you can see that I have these Pokemons being displayed, and then we have the Skeletonizer working as well. So if I reload, when the data is being loaded, you see a skeletonized version of our list tile, otherwise we don't. If I go ahead and I remove this string, and let's just say that we show an empty string, and I do command save, and I restart my application, you're going to see that the skeletonization doesn't work. And the reason for that is because for the Skeletonizer widget to actually understand how to skeletonize the actual list tile or any widget that's underneath of it, it needs to have these actual widgets have some structure to them. So what I've decided to do is just add some arbitrary values, some arbitrary information to these different widgets that I have, so that when they are skeletonized, they're skeletonized appropriately. So that's why as a placeholder, I've just added the following currently loading name for Pokemon. And if I do this, then the actual title is correctly skeletonized. So that's the reason I'm doing it like this. So once this is done, let's do the subtitle next. So for the subtitle, I'm going to say that it's going to be a text widget as well, but it's going to have the following text: has, then how many moves our Pokemon has, and then after that we're going to have space moves. So it's going to have, for example, has 0 moves. And then here I can actually add the moves. And to interpolate the actual variable, I can do $sign and then these squiggly brackets, Pokemon question mark dot moves question mark dot length. And there we go. That's pretty much all we have to do. And then .toString. And if this is null, then I'm just going to do 0. There we go. So let's do save. It's showing me has 86 moves, has 83 moves, has 96 moves for all of these different Pokemons. If I restart it, we're seeing that we're seeing the skeletonization appearing properly, as you can see. So it's all looking good. So now we can move to the next part. And the next part is to show our image. So for the image, I am going to, on the list tile, set the leading property. So the leading property is going to be dependent upon the Pokemon. If the Pokemon is not equals to null, then we're going to show a circle avatar. Otherwise, we're also going to be showing a circle avatar. But the first circle avatar that we're going to be showing is going to have a background image. And that background image is going to be of type network image. And then the URL here we can access from Pokemon.sprites. And then front default. There we go. That's pretty much all we have to do. Let's do command save. And there we go. We're seeing all of these wonderful Pokemons being displayed. But now if I reload my application, you can see that the skeletonization looks nice as well. It looks good. It looks the way it's supposed to. There we go. And once we have the information, then we see all of the information being displayed. So now with this done, the last thing that I have to do is basically add the trailing property. So for now, we don't have the actual functionality implemented for favoriting a Pokemon. So all I'm going to do is set the trailing property to be an icon button. The icon button is going to have an onPressed callback, which is going to be an empty function for now. Then it's going to have an icon, and the icon for now is going to be icon, and then I can do icons.favorite. And we can do favorite border. There we go. Let's do command save. And there we have it. That's pretty much all we have to do. We're seeing these different icon buttons. We can click on them, but nothing happens. But now we have this beautiful list tile that is being displayed to us, and it's displaying all of these different Pokemons to us. So now the next thing that we're going to be doing is that when we reach the end of this list, actually implementing pagination so that we can load more Pokemons and keep the list infinitely scrolling. So to implement pagination, what we're going to be doing is firstly coming to our home page and then coming to where we have our all Pokemon's list and basically to our list view. And to this list view, I'm going to be attaching a controller. By attaching a controller, we'll be able to get notified once we reach the end of our actual list, and then we can call a certain function within our actual provider to load more data. So for now, we can see that our list view, if we scroll to the very bottom, it kind of stops at the eradicate Pokemon. And what I'd like to do is once we reach the end, kind of call a function so that we can load more data. So this is how we're going to be doing it. The first thing that we're going to be doing is basically creating a scroll controller. To do that, I'll come to the very top of my homepage state class. And then here I'm going to be creating a variable, and I'm going to say that this variable is going to be final of type scroll controller. And then I'm going to say that this is going to be called all Pokemon lists scroll controller. There we go. And once this is done, I'm going to set it to a new instance of scroll controller like so. And that's pretty much all we had to do. So with this done, I can actually take the scroll controller and then set the controller to be this all Pokemon's list scroll controller like we have done. Now with this done, I will restart the app just to make sure that nothing's broken. And with that, we can come to the next part. So for the next part, what I am going to be doing is basically adding to my homepage state class the init state function as well as the dispose function so that I can set up a listener on this actual scroll controller. So to do that, before the build function, I will basically override the init state function for this class. And I'm also going to override the dispose function for the class. So dispose is basically going to be called once this widget is going to be removed, and init state is called before the build function is called when the actual widget is being initialized. So now that this is done, all I have to do is basically take my all Pokemon's list scroll controller, and after the superclass's init state function has been called, is to let it know that, hey, all Pokemon scroll controller, add a listener. And the listener is going to be a function that I am going to define now. So to define the actual function, I am going to say that in this class, before the build function, I'm going to do void underscore scroll listener like so. And then I'll open up the function's body. And then what I will do is basically say that this is going to be the actual function that is going to be added as a listener function to our Pokemon list scroll controller. Once this is done, the next thing that I'm going to be doing as a good practice is that before my superclass's dispose function is called, basically go ahead and from this Pokemon list scroll controller, remove the actual listener, which is our scroll controller. There we go. And once this is done, then what I can do is actually take my controller and dispose it so that we do not have any memory leaks. Then once this is done, I can restart the application once more to ensure that nothing's broken. And now we can finally start working within this actual listener function that we've created to get notified every time the user scrolls on the actual list. So what I'd like to do is basically have an if condition here, and I am going to determine if we've reached the end of our list. If we have, then we are going to be calling a function to load more data. So to do that, I will do if, and then we can actually say all Pokemon list scroll controller dot offset is greater than or equal to, and then I can do all Pokemon scroll controller like so dot, and then I can do position dot max scroll extent and multiply this with 1. That's pretty much all we had to do. You can multiply this with different values to actually change how soon within the actual scrolling list do you want to get notified that you've kind of reached the end of the list, and then call the actual function to load more data. I've just set that to 1, but you can experiment with this value to maybe load information much sooner than before the user actually reaching the end of the list. And now that this is done, we're also going to have another condition. So I'm going to use an AND clause, and that is going to be that our all Pokemon list scroll controller dot position dot out of range, and that this is not out of range. So there we go. So now that this is done, I can actually open up the if block. And within this if block, for now, I'm going to print reach end of list. So with this done, let's actually test this out. So to test this out, I will open up the debug console. And in the debug console, what I'm going to be doing is making sure that we don't have anything being printed as of now. But once I start scrolling and reach the end of the reach, you can see that it says reached end of list. And there we have, now we're getting notified that, hey, we've reached the end of the list. So now we can actually here access our actual homepage controller by doing underscore homepage controller and then dot, and then we can do load data. So if you remember correctly, the last time when we were actually coding the logic for the load data function for our homepage controller, we had left the else clause empty here for the case that if the state.data was not null, which means we already have some data, then we need to use the next URL to go grab the next set of Pokemons and then add that to the actual list that we currently have. So that is what we're going to be doing now. So to do this, it's going to be as follows. The first thing that I need to determine is that do we even have a next URL? So to do that, it's going to be as simple as doing if state.data.next. So if this is not null, then we can proceed, and then I can use a nullifier operator here to get rid of this error. So if the next URL is not null, this means we still have more Pokemons we can fetch. So now what I'm going to be doing is the same thing I had done before, where I'm going to be basically using the HTTP service to get the specific Pokemons. But this time, the actual URL that we're going to be using is not this one, but it's actually going to be state.data.next. There we go. That's pretty much all we had to do. So now that this is done, we can move to the next step. And for the next step, we need to ensure that the response that we get, it's not null. So I can do if response, and then I can do not equals to null, and then I can do response.data is not equals to null. Then what we can do is move to the next step. So for the next step, all I need to do is basically first take the response that we get and transform that into an instance of Pokemon list data. So that's going to be same as before. I will do Pokemon list data, and then I'm going to do data is equals to, and then I can do Pokemon list data dot from JSON and pass the response data here like so. And that's pretty much all I had to do. And now that this is done, the last thing that I need to do is update my state with this new data that I've gotten. So to do that, I'm going to do the following. I'm going to do state is equals to state.copy with, and then I'm going to say the data is going to be as follows. And here I'm going to do the following. I'm going to say that the data is going to be all of the previous Pokemons that we have, plus these new Pokemons that we've gotten that are within this data list. So how can I do that? Well, for this, I can use the following spread operator. So I'll create this empty list. And within this empty list, I'm going to say that firstly, I'm going to be adding all of the Pokemons that were already existing within the state. So for that, I can do the spread operator dot like so, and then do state.data.results. And then since this value can be null, we can use a nullifier operator, and then that is going to fix the issue for us. And once this is done, the next thing that I'm going to be doing is adding the new Pokemons that we've gotten to the list as well. So for that, I can do ... question mark and then data.results. And that's pretty much all we had to do. The last thing that I'm going to be doing is that on this data, I'm going to do data.copy with function, and then I'm going to say that the actual Pokemon here are going to be results like so, and that's pretty much all we had to do. And then I can use a nullifier operator here as well. So what I'm doing is basically updating the state's data property with the new data that we sent, which is going to be data.copy with, and I update the results to include not only the results that we already had for the previous Pokemons that we had loaded, but now to this list add the new Pokemons that we had just fetched from this actual data variable. So with that pretty much completes the actual implementation for pagination. So all that's left is to actually test it out. So let's restart our application. We can see the Pokemons being loaded. I reached the end of the list. And there we go. We started loading more Pokemons because the last time it had ended at Eradicate. But now we're loading more Pokemons, and I can keep scrolling. It'll keep loading all of these Pokemons till we reach the very end, because when we reach the end, then there are going to be no more Pokemons to show us. But there we go. That's working now, and we can move on to the next step. And for the next step, we're going to be taking a look at how we can actually favorite Pokemons. And then to display them, that's going to be the third step. So let's do that. So to do that, what we're going to be doing is basically creating another provider. And this provider is going to be responsible for providing us with information regarding the Pokemons that the user has favorited, and then managing all of the other relation when it comes to favoriting Pokemon, such as saving this information within the device's persistent storage using shared preferences and things like that. So this provider is basically going to be responsible for all of the logic like that. So a good place to put a provider like this is going to be your providers folder. Why? Because this is a provider that's going to be used all across your application, similar to how we're using this Pokemon data provider that we had created. And this provider is also going to be a state notifier provider, and it's going to be a little bit different from our actual homepage controller that is also a state notifier provider, but this is just going to be a little bit different, and we'll take a look at it now. So now I'm going to come to the providers folder, open up the Pokemon data providers, and here I'm going to be creating this new provider. As I had mentioned before, this provider is going to be of type state notifier. So let's do that. So I'm going to say that this provider is going to be of type state notifier provider. So what I need to do is firstly create a class that extends state notifier so that I can create a provider from that. So to do that, I will do that. I'm going to have a class, and this class is going to be called favorite Pokemon's provider. There we go. Then it's going to extend, and it's going to be a state notifier. Then if you remember before, the state notifier needs to be told what type of state is it going to be managing. In this case, I'm going to say that this state notifier is going to basically maintain a state which is going to be a list of strings, because basically when the user favorites a Pokemon, the only information that we're going to be storing about the favorited Pokemon is the URL for that. So when the application starts up again, we can basically just get the data from the URL for the Pokemon, and thus we don't have to save anything else. So the state notifier is going to basically maintain the state, and the state is going to be of type list string. There we go. So now that this is done, the next thing that I'm going to be doing is that I'm going to be defining the constructor for this actual class, like so. And then once this is done, I'm also going to be adding the superclasses that needs to get passed to it, which is the state. So now that this is done, we can actually move on to the next part. So for the next part, what I am going to be doing is that on the favorite Pokemon's provider constructor, I'm going to be saying that when the favorite Pokemon's provider class gets constructed, I want to call a function which is setup, like so. And then what I'm going to be doing here is basically just defining this function, so future void, and I'm going to say it's going to be underscore setup, like so. And then I'm going to mark this function as async and open up the function's body, and I'll leave it empty for now. So now that we've created our favorite Pokemon's providers class, it extends straight notifier. The next thing that we have to do is, using this class, create a new provider, which is going to be of type state notifier provider. So if you remember before, to do that, what we're going to be doing is basically doing the following. I'm going to create a new variable, and I'm going to say that this is going to be called favorite Pokemon's provider, and it's going to be equal to state notifier provider, like so. Once this is done, the state notifier provider basically expects to get past a function, which takes in a widget reference, and then we need to return whatever state notifier we're using. So in this case, we're going to be returning our favorite Pokemon's provider, like so. And then we need to pass it an initial state. So to begin with, the user is not going to have any favorite Pokemons. So we can just basically pass in an empty list here, and that should suffice. And there we go. Now we've created our actual favorite Pokemon's provider. So now we can access it wherever we'd like to, read information from it, or interact with it. So there are a couple of places where we need to use our favorite Pokemon provider. One is within these actual list tiles that you can see, because these list tiles, when we click on this actual icon, are going to be then basically communicating with this actual favorite Pokemon's provider and letting him know that, hey, this is a new Pokemon that the user wants to add to its favorite list, or removing it if the user clicks on the button again. And besides this, within our homepage, we'll also require access to our favorite Pokemon's provider. And the reason for that is because we need to show the grid view with all of the favorite Pokemons that we have. So for now, let's actually take a look at how can we work or interact with this provider within our actual list tile, and then we'll take a look at how we are going to be then displaying these favorite Pokemons in a grid view on our homepage. So let's close down all of the files that are open except for Pokemon data providers.dart, and then I am going to come to the actual widgets, and then where it says Pokemon list tile. And here now what I'm going to be doing is basically implementing the mechanism which is going to allow us to interact with the favorite Pokemon's provider, and then also favorite Pokemons and unfavorite them. So let's do that. So to do that, the first thing that I need to do is basically get a reference to my favorite Pokemon provider. So to do that, I will come to the top of my class, and here I'm going to create a new variable, which is going to be of type favorite Pokemon's provider underscore favorite Pokemon's provider. And then I also need a variable in which I'm going to store the actual list of strings which correspond to the Pokemons that I like. So for that, I will do late list of string, and then this is going to be called underscore favorite Pokemons, like so. And there we have it. So now that this is done, I basically am going to come to the build function, and in my build function, I will basically access these providers and the data that it has. So to do that, it's going to be as follows. I'm going to do that the favorite Pokemon's provider is going to be equal to ref.watch, and then here it's going to be favorite Pokemon provider dot notifier. There we go. I've done that. And once this is done, then I'm going to do underscore favorite Pokemons is equals to ref.watch, and then it's going to be favorite Pokemon's provider, like so. And that's pretty much all I had to do. And with this, I can do command save. So now that this is done, it's going to give me an error. And again, the error is that the state notifier provider, favorite Pokemon's provider, comma, object optional can't be assigned to this variable. So to fix this issue, I'm going to come to my Pokemon underscore data underscore providers.dart file, where we're creating our state notifier provider for our favorite Pokemon's provider. And here I'm basically going to define, firstly, what the actual type for the state notifier provider is going to be. So that is going to be favorite Pokemon's provider. And then what is the actual state that it's going to maintain? Well, that's going to be a list of string. And hopefully by doing this, the error should be now resolved on the actual Pokemon list tile.dart. There we go. So now the problem's resolved. So with this done, we can actually restart our application and make sure that nothing's broken. So now what we can do is, using these variables, interact with our favorite Pokemon provider. But currently on our favorite Pokemon provider, we have no methods available to us to basically add a favorite Pokemon and remove it. So let's do that. So to do that, I'm going to say that I'm going to have a function for adding a favorite Pokemon. So I'll do void, and then it's going to be called add favorite Pokemon. It's going to take in a string URL, and then it's going to do the following, which is to update the state. So we're going to do state is equals to, and I'm going to do the following. To the actual list that I am currently maintaining, I'll firstly take all of the elements from that list, add that to this new list, and after that, I will add the new URL that just gets passed to us. And that's pretty much all we had to do. Then I will copy this function, paste it once more, but this time I'm going to say that we're going to call it remove favorite Pokemon. We'll still get a URL, but now I'm going to do state is equals to state.where, and this time I'm going to remove the actual URL that gets passed to us. So to do that, I will do state.where, and then every element that doesn't pass this test will be included, but the element that does pass the test will be excluded. So I will do the element is not equal to URL. So if that's the case, then we will include it in the list, otherwise we won't. And this will ensure that we remove the URL that gets passed in from the actual state that we're maintaining, which is a list of strings that contain the URLs for all of our favorited Pokemons. So the URL that do not match with the URL that we pass, they are not going to be excluded, but the URL that does match, that's going to be excluded. So with this done, that's pretty much all we had to do. So now with this done, let's actually come back to our Pokemon list tile and see how we can call these functions. So on my Pokemon list tile, all of this logic needs to happen within the actual list tile trailing icon buttons on pressed callback. So here, the first thing that I need to determine is, have I already favorited this Pokemon? If I have, then I need to remove it. If I haven't, then I need to add it. So how can I do that? Well, it's pretty simple. I'm going to do if, and then I'm going to do underscore favorite Pokemons dot contains. So if the favorite Pokemons contains the Pokemon URL for this actual widget, that means we need to remove it. Otherwise, we need to add it, and then I will use an else clause here. So to remove it, what we're going to be doing is favorite Pokemon's provider dot, and then I'm going to do remove favorite Pokemon and add the Pokemon URL here like so, and then do save. And in the else clause, I will basically copy this, paste it once more. I'm going to do add favorite Pokemon. And there we have it. That's pretty much all we had to do. So now the last thing that I need to do is basically come to my icon and basically determine the icon's color and what the icon is going to be if the Pokemon is favorited or if the Pokemon isn't favorited. So how can we do that? Well, on the icon, the first thing that we need to determine is what icon we're going to be using. So I'll do the same thing. I'll say if the favorite Pokemons dot contains our Pokemon URL, that means that the Pokemon is favorited. So I'm going to do icons dot favorite like so. Otherwise, we'll do favorite border. And now that this is done, the last thing that I'm going to be doing is doing color is equals to colors dot red. There we go. So now with this, let's test it out. So to test it out, you can see that to begin with, all of the icons are just showing a empty heart. And then if I click on one of these, let's do Charizard. There we go. We favorited it. And now our icon is showing the complete filled favorite icon. And this pretty much means that it's working as intended. If I click on it again, we remove it. If I add it, we do it once more. But now if I restart my application, you're going to see that all of this data is lost and Charizard is no longer favorited. I can favorite him again, but if I restart the application, all the data will be lost. So what I need to do is implement some kind of a mechanism between my favorite Pokemon provider so that it uses shared preferences to actually persist this information on the device. So let's do that. So to do that, the first thing that I'm going to be doing is coming to my services, and here I'm going to be creating a new file, and I'm going to call this database underscore service dot dart. Then within this file, I'm going to create a class called database service. And as the name suggests, the database service will be responsible for providing us with all of the functionality we need to interact with our application's database. I'm going to define the constructor for this class. And then after that, I'm going to say that the first function that we're going to have is a function that is going to return a future Boolean optional value. And it's going to be called save list. And the thing that we're going to be doing is basically taking the complete list of string and then saving that within our device and then retrieving the complete list of string whenever we need to retrieve it when we actually restart our application. So shared preferences has a method on it which allows us to by itself just save a complete list of strings on the actual device. So then what I need to do is to work with shared preferences. We need to pass two things. One is the key against which we're going to be saving the value. So the key has to be of type string, and then the value is, this case, is going to be of type list string, and then I can do value. There we go. And once this is done, the next thing that I'm going to be doing is marking this function as async. Within this function, I'll implement a try catch block. Within the actual catch block, I'm just going to print the error and then return false, basically signaling to the user that if we reach the end, that the operation failed. And then what I'm going to do is access shared preferences first. So to do that, I'll create a variable final shared preferences. So this comes from the actual shared preferences package, call it prefs, and then set it equal to await. And then I can do shared preferences.get instance. There we go. And once I have access to the instance, then I can do bool result is equals to prefs dot, and then I can do set string list. And the key here is going to be the key, the value is going to be the value. And the last thing that I need to do is basically make sure that I await this. And then we can just return the result. And there we go. Our function for saving the list has been created. Then I'm just basically going to be copying the same function. And I'm going to say that now we're going to create a function for getting the list. So to get, like, I will do get list. And we just need to pass a key. It's going to return a future, but this time it's going to be a future list string. Optional. There we go. And once this is done, I'm going to say that I'm going to access shared preferences once more, but this time I'm going to do prefs.get string list. We get the key passed to us, and then what I'm going to be doing is basically saying that the type of the result is going to be list string optional, and then we'll return the result. And if we reach the very end, we will just return null. So with this done, I've created my save list function, allowing me to save a list of string. And I've created my get list function, which will allow me to get a string list if I pass a appropriate key. So what I'm going to do now is come back to my main.dart file, and similar to what I'd done before for the HTTP service, basically copy this command and paste it again. And here I'm going to do get.instance.register singleton, but this time it's going to be database service. So we're going to be using the getIt package to also register our database service and then access it. And that's pretty much all I had to do. So now I can actually come back to my Pokemon data provider and then to my favorite Pokemon's provider. And here I can actually access my database service. So to access my database service, I am going to do the following. I will create a variable, and I'm going to say that this is going to be final database service. And then I'm going to do underscore database service is equals to, and then do get it dot instance dot get. And what is the actual service that we're going to be getting? Well, it's going to be of type database service. There we go. So with this done, let's give a quick restart to our application to ensure that nothing's broken, no errors, so that's a good sign. And now we can use this actual function. So to use it, it's going to be very simple. When we actually add a Pokemon, so basically favorite a Pokemon, once I've updated the state, then I'm going to do database service dot save list, and then I need to pass it a key and a value. Well, the value is just going to be state, so we can pass that. What the key is going to be? Well, for the key, what I will do is basically on this actual favorite Pokemon provider, create a property string, which is called favorite underscore Pokemon underscore list underscore key, and set it equal to the same as the name of the variable. And then we can use this as the key that we're going to be saving our actual list against. There we go. And then when I remove a Pokemon, I want to do the same thing. So just call database service.save list again. And since we've updated the state, it's going to save the new list, and that list isn't going to contain the URL for the Pokemon that we had just removed. So there we have it. Now we're actually using the database service to persist the state of our favorite Pokemons. And the last thing that we need to do is basically within the setup function, create the logic for when the actual favorite Pokemon provider gets created, then actually access information from our database service and then load that within the actual provider. So let's do that. So let's restart our application, make sure that nothing's broken. And for the setup, it's going to be very simple. The first thing that I'm going to be doing is creating a variable. I'm going to say that this is going to be list string optional. Then I'm going to say it's going to be equal to result, and I will do await underscore database service dot get list this time and pass it the favorite Pokemon list key. And once that is done, then what I'm going to be doing is basically saying that the state is going to be equal to result. But if I do this, you're going to see that we get an error saying that list string optional can't be given to list string. So what we can do is use a nullifier operator and say the following, that if result is null, then we just set the state to be an empty list. Otherwise, we set it to be whatever the result is. And that's all we had to do. Now we've actually implemented data persistence within our actual application, and all of this logic is contained within the actual favorite Pokemon's provider and the database service. And this ensures that one, it's easy for us to extend upon our application. We can also localize most of our business logic so that we don't create any spaghetti code. And it's easy for other people to understand what's going on. And it's ensuring that you are following good developer practices and that you're minimizing the actual technical debt that you're creating while you're building your application. So now with this done, we can actually test it out. So if you remember before when we were saving Pokemons, when we would restart our application, it wasn't persistent the state. But now let's just say that I favored Venusaur, and then I favored Charizard, and I favored Blastoise. And if I restart the application, you can see that those Pokemons are still favorited. Why? Because that information is loaded from the favorite Pokemon's provider, and then our Pokemon list hull appropriately reads these favorite Pokemons, sees which of them are favorited, which aren't, and then updates these icons to be the appropriate ones. So there we have it. Now we've implemented pagination using a state notifier provider. We've also implemented the ability to favorite Pokemons using a state notifier provider. And we've actually implemented the functionality of loading data for a particular Pokemon using an actual future provider. So you can see the power of Riverpod and how powerful it is, hopefully by this point in the video. So now what we're going to be doing is actually focusing on adding the next part to our homepage, which is going to be at the very top, which is this grid view, which basically shows us all of the different Pokemons that we have. So let's take a look at it. So to show our favorite Pokemon's grid view, the first thing that we need to do is basically access our favorite Pokemon's provider within our actual homepage. So let's do that first. So to do that, I'm going to be coming to my actual homepage. And then here, I'm going to be doing the following. I'm just basically going to be accessing the data from our favorite Pokemon's provider. I don't need actually access to the providers itself. I just need access to the data so that I can just display it, since we're not going to be doing anything else. So to do that, I will come to my homepage, and here I'm going to be now creating another variable. This variable again is going to be a list of string. And then I'm going to say that this is going to be underscore favorite Pokemons. There we go. Once this is done, then I'm going to basically take this and mark this variable as late, and then come to my actual build function. And here I am going to say that favorite Pokemons is going to be equal to ref.watch. And then we can do favorite Pokemon's provider. There we go. That's pretty much all we have to do. So with this, let's do command save and make sure that nothing's broken. Let's restart our application. And now we're going to be saving the actual favorite Pokemon's list within this favorite Pokemon's variable within our actual homepage state. So now we're going to be able to use it to then actually generate our grid view. So let's do that. So to do that, I'm going to be doing the following. I'll come to my build UI function to where I have my actual column and then its children's list. For now, we just have our all Pokemon's list. So before that, I'm going to be adding a call to a new function, and I'm going to call this underscore favorite Pokemon's list. Then I'll come within the bottom of this class, and before the all Pokemon's list function, I will define my favorite Pokemon's list function. I will say that this function will get a build context passed to it, and then actually open up the function's body. For the favorite Pokemon, I am going to be doing the following. I'm going to return a size box, which is going to have a width, which is going to be the width of our screen. And then the child for this is actually going to be a column. Once this is done, I'm going to set the children for the column to be an empty list for now. And let's give it a test run. Everything looks good. So now that this is done, the first child within this column is going to be a text which says favorites. And there we go, we can see it. And then I'm going to set the main axis alignment and cross axis alignment on this column to be the start for main axis and start for cross axis. Once this is done, I'm going to come back to my columns children list, and after the text, I am going to be adding a sized box. And this sized box is going to contain our grid view. So I need to give it a specific height in the width. So the height will be 50% the height of the screen, and the width will be 100% the width of the screen. So there we go. This is the actual space now being shown to us. Within this sized box, once again, I am going to be adding an actual child, and this child is actually going to be a column. And the reason I'm using a column is because dependent upon if we have favorite Pokemons already within our list, then we're going to be showing a grid view. Otherwise, we'll show a text which basically says that there are no favorite Pokemons. So now within the children's list for this actual column, I'm going to set that to be empty. And the first thing that I'm going to be doing is basically addressing what's going to happen if we don't have any favorite Pokemons. Well, if that's the case, then I'm going to do if underscore and then favorite Pokemons dot, and then you can do is empty. So if our favorite Pokemons list is empty, then I'm basically going to be just returning this actual text widget and adding that to our column as a children's list. And then on my column, I'm going to set the main axis alignment and cross axis alignment to be center and center. For now, since we have some Pokemons favorited, we're not seeing this, but as soon as I remove all of these favorited Pokemons, let me show you, you're going to see that now we're seeing no favorite Pokemons. So now what I can do is actually address the logic for when we have favorite Pokemons, then showing a grid view. So for that, it's going to be fairly simple as well. I'm going to do underscore favorite Pokemons is not empty. So if they are not empty, then what are we going to be doing? Well, in that case, what I'm going to do is actually return another grid view, but this time we're going to be doing grid view.builder. And then it needs to have a grid delegate defined for it. So what's the grid delegate here going to be? Well, a grid delegate for a grid basically defines some certain settings for the grid to let us know how many elements this grid is going to have on its cross axis. So for example, our grid is going to be horizontally scrollable. So the actual scroll direction is going to be horizontal. And then the cross axis for this is going to be the vertical axis, because the main axis is always the axis that you scroll against. So on the main axis, for every row of our grid, I want 2 elements there. So to do that, I'm going to say that our grid delegate is going to be this const sliver grid delegate with fixed cross axis count. And I'm going to say that the cross axis count is going to be 2. Once this is done, the next thing that we have to do is basically define how each of the child for this grid view is going to be built. So for the item builder, we're going to get a context and an index passed to us. And then we, for now, can just return a container. And that's pretty much all we have to do. With this, let's do command save. And let's restart our application and make sure that we do not get any errors. So we are actually getting an error. So to fix this, what you can do is actually come back. Oh, and I can see what you can do is actually copy all of this grid view logic and actually add a sized box. And the child for this sized box is going to be our grid view. This should pretty much fix the issue for us. And then I can set the height for this actual grid view to be the following, which is media query.size of context height times 0.48. So with this, let's actually restart our application. And if I do that, hopefully we're not going to be seeing any more errors, and we are not. So we can move on to the next step. So for the next step, what I'd like to do is basically create another widget, which is going to be a class that's going to be responsible for showing these Pokemon cards with some certain information for the Pokemon within them, as you can see. So to do this, the logic is going to be the same. The first thing that I'm going to be doing is coming back to my widgets and creating a new file here. And this file is going to be called Pokemon_card.dart. Then within this, I'm going to create a class which is going to extend consumer widget. And the reason we're doing that is because within this actual Pokemon card, we're also going to be using our actual Pokemon data provider to pass it the URL and then get the data for that specific Pokemon. So let's actually import this consumer class from Flutter Riverpod. And then on this actual Pokemon card class, I need to define the actual build function like so. And that's pretty much all we have to do. So now with this done, for the build function, what are we going to be doing? Well, I'm going to be firstly accessing my Pokemon data provider, which is within this Pokemon_data_providers.dart file here, as you can see. And then passing it a URL so that we can display the Pokemon's information within these cards as well, as you can see here. So let's do that. So to do that, Similar to what we had done for our list tile, when we create a Pokemon card, we have to pass it a URL for the Pokemon that it's going to show information for. So to do that, we can easily just add a property to this Pokemon card class called Pokemon URL. Then basically create the constructor for this class and say that when it gets constructed, it has this required argument called Pokemon URL. And that's pretty much all we had to do. And then to fix this actual issue, we can actually add the key constructor here as well. And then it's telling us that we can actually mark this as a constant. So let's do that for now. Then for the build function, for now, we can just return a container. And there we have it. And now I can remove this actual import statement that we have here. And there we go. Everything looks good. So with this done, I can come back to my home_page.dart. I can come to my sized box, then to the grid view, it's item builder. And here, instead of returning our container, now what am I going to be doing? Well, instead of this, now I'm going to be returning a Pokemon card. And then here, the Pokemon URL is going to be dependent upon which actual Pokemon we're rendering from our favorites list. So let's do this first. Let's come on our grid and define the item count to be favorite Pokemons.length, like so. And then here I can do the following, which is Pokemon list data, or list result, I should say. And then I can do Pokemon is equal to _ favorite Pokemons, and then the specific index. And that is pretty much it. And it's going to give me an error that it's going to be Pokemon list result and a value of type string. So yeah, this needs to be string here. And then this needs to be Pokemon URL. And then we can just pass it to our Pokemon card, and that's pretty much all we had to do. So let's do save, and hopefully we have no errors. So we can come back to our Pokemon card and now do the rest of the stuff here. So the first thing that I need to do is using this Pokemon URL, interact with my Pokemon data provider, pass it the URL, and get the data from it. So to do that, what am I going to be doing? Well, it's the same as what we had done before. On my actual build function, I know that I have a widget ref to pass to me. So before I return the container, I'm going to do final Pokemon is equals to, and then I can do ref.watch. And then here, I'm going to do Pokemon data provider. We got to pass it the URL, which is going to be our Pokemon URL. And that's pretty much all we have to do. And since these different providers that we are creating, for example, in the case of our Pokemon data provider, we're going to be creating a bunch of different Pokemon data providers, each of them corresponding to a specific URL. As long as there's at least one widget that's within our complete application that's listening to this actual provider, the state of this provider is going to be maintained. So we're not going to be resending requests again and again. The provider framework is going to make sure that it caches the data for us. The only time that this provider is going to be destroyed is when there's no consumer that's listening to it. So hopefully that makes sense. What I'm trying to say is that as long as the consumer is attached to a particular provider, that provider is going to maintain its state and cache the data within it, as long as we do not do some kind of an operation on it to maybe update its state or anything like that. So this was just a side note. We can now come back to our Pokemon_card. So once we have the actual return type, which is going to be of type async value, saved within this Pokemon variable, I'm going to be doing the same thing. The first thing that I'm going to be doing is basically creating a function, returns a widget, call it card. It takes a build context passed to it. Besides this, it takes a Boolean value for whether it's loading currently. So I'll do bool is loading. And then besides that, it also takes a optional Pokemon like so. And then it returns, for now, we can say a container. There we go. So with this done, I can import this Pokemon class from /model/Pokemon.dart. And then I can come to my build function and say that return Pokemon.when. And we're going to be doing the same thing as we had done before for our list tile. When we have the data available to us, then we're going to be returning a call to our function card. We'll pass it the context. Loading is going to be false, and the Pokemon will be the data, like so. And in the case we have an error, then what I'm going to be doing is basically taking in the error and the stack trace, and then we are going to be returning an actual text widget that will basically let us know what the error is. And you can implement better error handling if you'd like, but for the purposes of this tutorial, this should suffice. And then finally, for the loading state, we're going to do the same thing. We're not going to get any parameters passed to us for this callback function. But here, I'm going to return a call to our card function, but the data is going to be null, and then isLoading is going to be true. And this is the part of using these future providers, as they make it very easy for us to implement proper data fetching logic within our application. So now that this is done, I can come to this card function and we can start building the actual card. So if you see, we have this card, which basically has the Pokemon's name, image, moves, and then whether we favorite it or not. So let's do that. So to do that, it's going to be as follows. The first thing that I'm going to be doing is adding an actual margin to my container. And then after the margin, I'm going to be adding some padding as well. Then I'm going to define the decoration property on the container, which is going to be of type box decoration. And then I'm going to say that the color for this actual container is going to be derived from our theme primary color. So let's do that. And as you can see, since we have one favorited Pokemon, that card is appearing. If I add another one, let's do War Turtle. There you go, we're seeing another card being displayed. If I remove it, the UI is updating in real time, as you can see. So now that this is done, the next thing that I'm going to be doing is setting the border radius on this. So the border radius is going to be 15. There we go. And then after this, I'm going to define the box shadow on this, which is going to be the following. And now we have a box shadow behind the card. So now with this done, on my actual container, I'm going to define the child, which is going to be a column, and the column is going to have a children's list. So what are the children here going to be? Well, I'm going to have a row. After that, I'm going to have an image and then another row. And the first row is going to contain the name and the ID. Then we're going to have an image, and the second row is going to contain the moves and this button. So let's do that. So to do that, I am going to, for the column, define the main axis alignment and cross axis alignment to be the following. So main axis is space between, cross axis is center. And then the children's list is going to have a first element as row, which is going to have a children's list within it, like so. So for this row, I need to show the Pokemon's name. So let's do that first. So I'm going to add a text here, and that is going to depend upon whether the Pokemon has a name or not. So I will do the following. I'll say Pokemon.name.to uppercase. And if this is null, then we just say Pokemon. And the reason I'm returning these default values is so that the Skeletonizer works as intended. So now that this is done, we can see Charizard. Then what I'm going to do is update the styling for this. And now we can see Charizard in white. The next thing that I'd like to do is basically copy the same text, paste it once more. But this time it's not going to be Charizard. It's actually going to be the ID of the Pokemon. So to do that, I will say that the text is going to be the string. It's going to do hashtag or #, and then after that, I will interpolate the value of the Pokemon's ID. So for that, we can do $, squiggly brackets within which we can do Pokemon.id and then .toString. And that's pretty much all we had to do. So let's do save, and I can see the ID being shown here as well. To add some spacing within these, I'm going to come to my row and set its main axis alignment to be space between and cross axis alignment to be star. And there we go. Now there's some space within them. So with this done, let's implement the Skeletonizer on this card as well so that we can show a beautiful loading animation. So on my container, I am going to right click on it, and then you can do refactor, or on Mac, you can do Control-Shift-R. Windows should be something similar, and then wrap with widget. The widget is going to be a Skeletonizer widget. And then here, we're going to say enabled is going to be dependent upon is loading. And that's pretty much all we had to do. So now let's restart our application, and hopefully the card should appear with this skeletonized version that you're seeing here for the titles. What I want to do is ignore this container behind. When we don't have data, then I don't want to show the background container. For that, what you can do is on the Skeletonizer, there's a property called ignore containers. You can set that to true. So if I set ignore containers to true, and then I restart the application, you can see that we see this much more beautiful loading animation here. It's a little bit more difficult to see, but the Skeletonizer is ignoring the background container and only skeletonizing like the texts that are within the row. So with this done, we can move to the next part. So for the next part, I'd like to add an image here. So for the image, we're going to be adding that to the column. So after the row that we just added to our column, the next child here is going to be an image. So let's do that. So to do that, I'm going to add an expanded widget, which is going to have a child. And then that child is going to be a circle avatar. Then that circle avatar is going to have a background image. And then that background image is basically going to depend upon whether we have a Pokemon or not. So if we have a Pokemon, then what I'm going to do is say that it's going to be equal to network image. And then the URL here is going to be Pokemon.sprites. And then we can do front default, I believe. There we go. And add these exclamation mark here to ensure that we do not get an error. And then if this is not the case, if we don't have a Pokemon, then I'm just going to say that the background image is going to be null. Let's do save. And there we go. We can see the Pokemon. The last thing that I'm going to be doing is that on this actual circle avatar, I'm going to define the radius to be mediaQread.sizeOf context. And then I can do .height and then multiply that with 0.05, save. And there we go. Now the actual size of the image has been increased. So now what I need to do is add the remaining last row. So after this expanded widget that I've added, I'm going to be adding a new row. This row is also going to have a children's list. And then within this row, we're going to have two things. We're going to have how many moves this Pokemon has, as well as this heart button that we can click on to remove a Pokemon from our favorites list. So let's do that. So for the text, it's going to be very simple. We're going to have a text widget. And this text widget is going to display some text within it, which is going to be how many moves the Pokemon has. So for that, we can interpolate within the string Pokemon.moves.length. And then I can say space moves, save, and there we go. We can see it. It says it has 131 moves. For the styling of it, I'll change the color to be white. And now it looks nice. So now if I restart our application, you're going to see that we're seeing this beautiful skeletonized version, as you can see, and it looks great. So now that this is done, the next thing that I'm going to be adding to this row is an icon, and this icon is going to be icons.favorite. And then it's also going to be colors.red. And the reason we do not need to check the state for the actual icon and what the color for this icon needs to be is for the fact that the Pokemon shown within our grid view are already going to be favorite Pokemon, so we don't need to determine whether we need to show a favorite icon or a favorite outline icon, because all the Pokemon here are already favorited. If we click on this icon, and we're going to take a look at how to do that, then we just need to remove the Pokemon from our actual favorite Pokemon's list. So now that this is done, what I'm going to be doing is coming to my row and actually addressing the spacing issues by setting the main axis alignment to space between, cross axis alignment to center. And now everything looks great. So now let's restart our application. Oh, it looks so good. And now if I go ahead, scroll through the list, and let's say that I set Butterby as a favorite Pokemon, it shows that. Pidgeotto, it's being shown. I can add Fearow, it's being shown. And if I add Pikachu, for example, now I can scroll through this grid view as well, but my grid view is currently vertically scrollable. So what I'll quickly do is come to my home_page.dart, come to my grid view and set the scroll direction to be axis.horizontal. And there we go. Now it's horizontally scrollable. Looks great. So now what I'd like to do is implement the functionality of when I click on these icons, remove this actual favorite Pokemon from our favorite Pokemon list. So for that, I need to access my actual favorite Pokemon's provider. So let's do that. So I will come within my Pokemon card, and within my Pokemon card, I'm going to create a variable which will store a reference to this actual favorite Pokemon controller. So there we go. And then once this is done, we have to remove the const from here on the Pokemon card. And then I will take this favorite Pokemon's provider, come to my build function, and then I'm going to do the following, which is favorite Pokemon's provider is equals to ref.watch favorite Pokemon's provider.notifier. And we do not need access to the actual list within this, so I'm not creating an actual variable to actually store the actual list of strings for the favorite Pokemon URLs that we have. So now I can take this favorite Pokemon's provider and come to my card, come to where I have my icon within the last row, wrap that with a widget. The widget is going to be a gesture detector. I'm going to say that when this widget gets tapped, I want this function to be called. And here I'm going to do underscore favorite Pokemon's provider dot remove favorite Pokemon, and then say that it's going to be Pokemon URL. And that's all we have to do. So with this, let's do save. Let's click on one of these. And there we go. That Pokemon is removed, as you can see, and it looks great. So it's working as intended. And if I restart the application, hopefully the only Pokemon that's shown is Fearow. So absolutely fantastic. Everything's working as intended. and everything seems to be working. So now the last thing that I'd like to do is basically implement a mechanism where when I click on one of these actual widgets, whether that's the list tile that we're seeing or these card, that it shows me a dialog which basically shows me the different stats for this Pokemon. So how are we going to be doing that? Well, to do that, let's do the following. Let's firstly go ahead and actually add a gesture detector on each of these different Pokemon cards so that when we click on them, we can get notified that, hey, you had clicked on them. So on my actual Pokemon card, I'm going to come to the point where after my Skeletonizer, I'm returning my container. I'm going to go ahead and wrap this container with a widget, and this is going to be a gesture detector widget. Then I'm going to say that on tap, and then this is going to be the function callback. So I only want to show the stats if we have the data loaded. So to do that, I can easily do if not loading. So if not loading is, which means is loading is false, then we actually show our dialog. So for that, I can do show dialog, and then we pass it the context and the builder. So for the builder function, I will ignore the actual argument that gets given to me, and then we have to actually return here the actual thing that we'd like to show. So what I like to show? Well, I'd like to show a custom dialog that I am going to create. So to do that, I'm going to come back to my widgets, and here I'm going to be creating a new file, and this file is going to be Pokemon underscore stats underscore card.dart. Then let's open this file up. Within this file, I'm going to say that I'm going to do class, and then it's going to be called Pokemon stats card. It's going to extend consumer widget. Again, this will require access to our Pokemon data provider. We're going to pass it a Pokemon's URL, and then it'll take that URL, interact with our Pokemon data provider, get the data from it, and then display the different stats to us. So when this Pokemon stats card gets created, I want the Pokemon URL to be passed to it. So we do that. And then I'm going to create the constructor for this class like so, and say that it's going to get a required named argument passed to it, which is Pokemon URL. So that's pretty much all we had to do. Then with this done, we need to implement the actual build function for this class. So let's do that. And then here for the build function, I am going to say that I'm going to return an alert dialog. And that's pretty much all we had to do, and do save. So now with this done, I can actually go ahead and come back to my Pokemon underscore card.dart file to my actual gesture detector that wraps the container. And here I'm going to say that we are going to return our Pokemon stats card when we click on this actual container like so, and do save. Now if I click on one of these, you can see that the dialog's being shown, but nothing's being rendered for now because our dialog doesn't contain anything. So let's come back here and let's start adding stuff to it. So for the title of this dialog, it's going to be the following, called statistics. So if I click on it, there we go, we can see statistics. Then what I'm going to be doing is that for the actual content for this actual alert dialog, I'm going to firstly get the information from my Pokemon data provider and then use that to populate the content. So let's do the same thing that we were doing before. Let's actually create a Pokemon variable, which is going to store the result from our Pokemon data provider. So within my build function, I'm going to do final Pokemon is equals to ref.watch, and then Pokemon data provider, there we go, and then pass it the Pokemon URL, and that's pretty much all we had to do. Save, and then I can take this Pokemon variable and do Pokemon.when. So when we have data, we return something else within the alert dialog. When we have an error, we return something else. When it's loading, we return something else. So what's the case for when we have an error? For the error, I'll just copy and paste it in because we've been doing this a lot. We basically just return a text which shows us what the error is. For the loading state, I'm going to return a circular progress indicator in this case instead of a Skeletonizer. And for the data, I'm going to say that we're going to get the data given to us, and then I am going to return a column. The column is going to have a children's list, which for now is going to be empty. So with this done, let's test it out and see if everything works as intended. So if I click on one of these, yeah, we're seeing this card and everything looks great. So now for my column, I'm going to say that the main axis size is going to be main axis size.min. And then for the children's list, I'm going to do the following. I'm going to take the data. On the data, I'm going to access the stats, and I'm going to map over all of the stats. And then the next thing that I'm going to be doing is using a null-aware access operator. And then in the case that the stats are null, or this returns null, we'll default to just using an empty list. And then here I can say map.toList. This should fix the issue for us. Then for the map, what I'm going to do is say that I'm going to get a stat given to me. And then for each of the stats, I am going to return a text widget like so. So with this done, let's actually test this out and see if it works as intended. Yeah, we can see the statistics being printed. So what is the text going to be? Well, it's going to be the actual name of the stat and then how much of that stat we have. So to do that, I will interpolate the actual stat's name by doing $ curly brackets s dot, and then we can do stat.name and then dot to uppercase. And then we can use null-aware operator on this to ensure null safety. And then once this is done, if I click on these, there we go. We can see HP, attack, defense, special attack, special defense, and speed. And now what I'm going to be doing after this is adding an actual exclamation mark, and then adding the actual value of the stat, which can be done by doing s.base stat. And that's pretty much all we had to do. So let's click on one of these. There we go. HP 65, attack 90, defense 65. If I do for Venusaur, it's HP 80, attack 82, defense 83. So everything looks good. So now what I'd like to do is basically replicate the same logic when I click on these list tiles. So for that, it's going to be the same thing. I'm going to come to my Pokemon list tile. I'm going to go to the very top where I have my list tile within this tile function. I'm going to wrap that with an actual widget. The widget is going to be a gesture detector. Then I'm going to say it's going to have an onTap function callback. And when it gets tapped, I want to run the same logic. So I'll just basically copy this same code and paste it here, which if it's not loading, then we show a dialog, Pokemon stat card, and there we go, import it. So let's test it out here as well. There we go. For Squirtle, we are seeing it. For Butterfree, we're seeing it. Now, if I click and favorite one of these, I can see it. When I click on Fearow, I can see it. If I restart my application, hopefully all of the information is being persisted. All of the Skeletonizer animations are looking great as well. And I can scroll through the list and Pagination seems to be working the way it should. And everything seems great. So with that, that's pretty much it for today's tutorial. I hope that you now thoroughly understand how to work with the Riverpod state management library, and you can use it to its fullest potential now to create awesome projects. As always, if you enjoyed the video, then please don't forget to leave a like on the video and subscribe to my channel so that you get notified every time I release a new video. And as always, stay happy, stay healthy, keep learning, keep growing, and I'll see you guys in the next video. Bye-bye.